Hello, this is Professor Brown-Sederberg, and I'd like to demonstrate a switch statement, the switch construct. You'll see that I have the beginnings of a program here. I've named it DemoSwitch. It begins here and ends here. We have a main method that begins here and here. Now within my main method I declare an instance of the class scanner. I've named it keyboard. I can do that because I have imported java.util.scanner up here. I've also declared an int that I'll call user input. Now I intend to put into that user input what I gather from the user, so I ask for that here and then get their input with keyboard.nextInt and store it into user input. Now what I'm asking the user for is a rating of a movie 1 through 3, and what we'll do is we'll use a switch statement to print to the screen a message, and that message will be determined by the value entered by the user. And we're going to use a switch statement. Now I could have done this with a nested if else. A switch statement very often replaces a nested if else. And a switch statement is very often a little bit more elegant and actually a little easier to write. Now there are limitations. I can only use a switch statement if the controlling expression, and we'll talk about a controlling expression, if that controlling expression is an int, an integer, or a character. It can't be a floating point or a Boolean. It has to be a specific value, can't be arranged, and with Java 7 can be a string. So that controlling expression that I'm talking about follows this, the keyword, the switch, and that establishes that this will be a switch construct. And what I have within parentheses is my controlling expression. That is what I want to compare values to. And I'm going to compare values to this, the user input that he gathered from the user. Now I'll bound my switch statement here and here, and within it I will determine the message to be printed to the screen, and I'll determine that message by comparing a value to this user input. Now I'll use this keyword case, and following that keyword I'll have the value that I want to compare to this, the user input. And so here I'm going to compare 1 to user input. Now following that value I have a full colon. That's a full colon, not a semicolon. If I have a match, this value, in this example 1, to user input, I will execute the code that follows this case statement until I encounter a break statement. So what I'd like to do here is just print to the screen, bad movie. So if it has a rating of 1, we'll just print that to the screen, and then we will break. And what a break does is it gets us out of the construct. If I matched 1 with this user input, this would print to the screen and I'm out of the switch statement, and whatever followed it, this code that might be down here, would be the next to be executed. I'll take care of the next case, which is the case of a value of 2. Remember, that's a full colon, and here I'll just print out that it's an average movie. That's what you get for a rating of 2, and we'll break. Our last is a case 3, and here we'll print to the screen, great movie. So our message that will be printed to the screen is determined by the value of my user input. Now I've taken care of the case of 1, 2, and 3, which is what I expect to get from the user. But clearly I have to know that the user might not give me what I expect, and so we have this, the default case, and this executes if I have no match before it. So my default will be that I'll just tell the user that they gave me some invalid input, and I'll break. Now I don't really have to have that break because this is the end of my switch statement, but it's good programming to have it. So here's a switch statement. I compare the value that follows the keyword case to this, the controlling expression. If I have a match, the associated code executes until I hit a break statement. All the code executes until I hit a break statement. I've taken care of what I expect to get from the user, and then if I get something unexpected. So let's see if this will compile. Alright, we have a clean compile, and we'll run. And I'll enter in 1, and I have bad movie. That's what I expected. I'll run again. With a 2, average movie. We'll run again. With a 3, great movie. Let's run it again. And with a 4, we're told invalid input. And that's exactly what we expect. Now, if I were to comment out this break statement, had I forgotten that break statement, I'll see that if I have 1 entered by the user, have not only this line printed, but also this one. So let's recompile, and let's run. And I'll enter in the value 1, and you'll see that I have both of these strings printed. And that's because once a match is made, all executable lines of code that follow will be executed until a break statement is encountered. So you have to be careful not to forget those break statements. But you'll also find situations where it makes sense to leave the break statements out because you want lines of code to be executed. So here we have our switch statement. We have our controlling expression. Our switch statement is bound by curly brackets always. We have here the keyword case and a value that we're seeing if it matches to our controlling expression, this example user input. If there is a match, we execute the code until we hit a break statement. There's no need for curly brackets in here because it's the break statement that controls what's associated. We always have a default statement to make sure that we take care of the unexpected, and here we have it here with a break statement at the end. So this is an example of a switch statement. It has a lot of uses. It's elegant code. It has some limits. Remember, this has to be an integer or a character or a string if we're dealing with Java 7. It cannot be a floating point or a Boolean. And here I can't use ranges. I have to have something that's a match. I can't use ranges in here. So while there are some limits, it still is very, very useful. And that's the switch statement.